Okay, hey everyone. So from the previous recording, we talked about classes, functions versus methods, and then called by value versus called by reference. We didn't have a chance to get into the house activity, but what we ended up doing was we made a toy. We did a toy activity. We made a toy class. We made a few functions. Essentially, for every private variable that you have, you need a way of changing them and getting what they are. Because they're private, that means that main down here isn't able to directly access them. So you have to have these things called getters, and so we made all these getters. And essentially what a getter does is it doesn't take in any arguments, and it returns it returns the thing that it's getting. So like this is get name, it's going to return name. The name of the function doesn't necessarily have to match up with the name of the actual exact variable, but it's a good practice. You should probably do that. But it's a way of obfuscating, of sort of hiding from main's perspective what your variables are called. Sometimes that's necessary. In the scope of this class and most of the classes at Cabrillo, that's not going to be necessary. So the thing that's really important to see with getters is getters get the value of it, so they're going to return it. They don't take in any arguments. As opposed to setters, setters don't give anything back, so they're going to be void. But they do take in a variable that matches the type of whatever they're setting. And one of the neat things about the setters is that you can check to make sure they're valid. So for example, here we have in set price. We make sure that the new price that's being changed isn't a negative, because maybe somebody, they hacked into the system and they were able to change the price, and they said, haha, now if I buy this thing, the store will owe me money, right? So this is a way of mitigating your losses so that maybe they can get something for free. So maybe you have something that's super discounted for free, and that's perfectly fine. But that if the store owes them money, that this won't accept that new price. Would be considered bounds checking in the sense of the bounds of this price variable, that you never want to see it to go negative. So yeah, for every one of these, you want to have setters and getters, and some of them you might check to make sure they have valid input. But for like a name, you might maybe check if the name is empty or whatever. But in this case, we're just immediately setting the name. We also talked about comments. Comments are really important. So this is an example of a comment block that goes to set name. We have the parameters, and then maybe if it wasn't a setter or a getter, I would have a little bit more description of exactly what it's doing. Set and get is pretty standard fare. So I don't need to say like I don't need to say in here this sets the or this changes the name to new name, right? That's not needed because it's pretty standard fare. But your other functions, or actually methods in this case, would be pretty obvious what they are. So yeah, so this is what we did. Yeah. Okay. So hey everyone, we're talking about constructors. So we made a default constructor right here. Sorry, I'm going on recording so I can catch everyone up. Made a default constructor here. This gets called every time we make an instance of this toy class. So this sets all of these. And these are all invalid states in the sense that if we ever looked at minimum age and we saw this -1, -1 could never be a minimum age, because down here we make sure that the minimum age is either 0 or above. And so that makes sure that if we ever look at it and we see -1, that we never set it at any point. Okay. So now what we're doing is we're making an overloaded constructor. Overloading just means using it again. And so this is the default constructor. And then this is going to be an overloaded constructor. And so we might just say, hey, this one right here only takes in the name. Oh, I'm missing a semicolon right there. There we go. So this one here, this constructor here only changes the name, and then it sets everything else to the default value. So this is one example of an overloaded constructor. It only takes the name. So if we made a toy, we know what it's called, but we don't know anything else about it, that is the constructor that we would call. And so in main, all it's going to look like is a toy and what's a toy? Oh no, a new one. I need a new toy.
Cart.
A cart?
Yeah.
Okay, so we have a cart, and so then what we do is now we add these parentheses, and then we put in our string. So we're going to name it cart, and there we go. So this is us. So this here, Bop It and Lego calls the default constructor. And then this cart is going to call that overloaded constructor that we made, because that's a string, and it's going to match. It's going to match it because it takes in a string as an argument. And we can keep overloading it. We can make as many constructors as we want. The thing, though, that we have to be careful of is that say that I wanted a toy that I only can put in its material, but not its name. What's the type of material? No, what's the type? The variable type. It's a string, right? And so the problem about it is that if I just copy and pasted this, and I had another one that said string and then new material, the compiler has no way of telling the difference between them. And so you can't overload the constructors with exactly the same type. So we could make an overload constructor that takes both the name and the type, the material type. We could do that because it's a string and a string versus a string and then another string, like a separate constructor. So you could have a constructor that takes in both of them. That's fine, but you can't have something that takes in arguments of the same type. So let me just show you what you can't do. So you can't do this because it has no way of telling the difference between. It has no way of telling the difference between the first overloaded constructor and the second one. So we can't do this because they're both strings. We can't do this because when the compiler looks at it and when running the program, all they see is this. They can't tell that this new material belongs to material. So these look the same to it because it's like, oh well, it's a constructor name point and it's some string. So and both of these are the same in that prototyping source. Like if you wrote the prototype for this, it would just be toy string and that would be it. You couldn't tell the difference. But if you have something that takes in a string and a string, then you're in business. So now let's overload it where we can set both the name and the material. So we can do this, and then this here. This is good because the prototype. So let's just say this prototype here just looks like this. If you were asked to make a prototype for this first overloaded constructor, it would look like this. This here would be toy string string. So this one, the prototype would be this. Right? Notice that this is different because it takes in two strings, whereas this one only takes in one string. And that was the problem that we had with just trying to change the material, was that the prototypes were identical. So the compiler couldn't tell the difference. So we would call this one where we could set both the name of the toy and the material. So what's another toy? A new toy. A new toy. Gotta be more original.
Barbie.
Huh? Barbie?
Yeah.
Barbie, okay, great. So, so we got a Barbie, and let's call that other constructor, the one that we just made, the one that takes the name and the material. So the name is going to be Barbie, and then what is the Barbie made out of?
I don't know.
It's plastic.
That's the word.
It's plastic, yeah. So this one allows us to change both of them, but the order is very important. So when we look at this, the name and then the material. So let's make sure that we did that properly in the constructor, because otherwise it's going to look really funny when we print out Barbie's name and it says plastic. So name, material. So we got the order correct. So we're in business. We're okay. So yeah, you want to make sure that when you call it, that you know the orders of these. So let's keep going. Let's keep overloading this. Let's make another one. So let's make one that its prototype takes in the price and the minimum age. So what is the type of price?
Double.
Right. So in the prototype, we're going to have a double. And what's the type of minimum age? Right, an integer. So here's the prototype. So notice that this prototype doesn't match any of the other ones. Because we have the empty one, we have one that takes in a string, we have one that takes in a string and a string. Now we have string, double, int. So it doesn't collide with any of the other ones. So we're okay. So now we might as well just copy and paste to this guy. And then let's add these in. So we've got our price, and we've got our minimum age. Oh, slow down. I don't want to slow down. And then minimum age. So stick the new in front of all of these so we're not shadowing. And then we'll set the price. And notice here that we don't do any of the checking. Right now, we're not doing any of the balance checking that we do in our settings. Like our set minimum age and set price, we don't do here. We could just have an if statement here, and that's perfectly valid. So you can, at the constructor point, do the same checks that you do in your setters and getters. That's up to you. It's always good to do. So here we could take in the same if right here, bink, and we have like an else that we that maybe we set it to we keep it at -1. So now, oh, semicolon. So now we check the age, and that if it's valid, then we set it, and if it's not valid, then we put it at -1 because we know -1 isn't the valid thing that we can check for. And that's the same thing that the default constructor does. If we look at the default constructor, minimum wage is -1. And the same thing with all the other constructors, we set it to -1. So in our main, or whoever's calling it, could always check for -1, that we keep this value. We can call it a sentinel. This obvious value that stays the same throughout everything. If age is ever invalid, it's going to be -1, and we can always check it. So you only need like one if statement if it's -1 to know it's invalid. Versus if each of these, this was -1, -2, -3, -4, it would be much harder to test. You would have to be like, oh, is it negative? And that's a much more expensive thing to check. And this would also be something that you put in your documentation. In your comment block for your toy, you would say, hey, -1 is the sentinel for this hasn't been ever changed, or that it's been tried to change and it's invalid. Okay, cool. So we've done that check, and we can do the same thing for price. We can just be like beep, and then price, and then else, we should set the price to the same sentinel of negative a penny. There we go. So now we've got default constructor, and we've got 3 overloaded constructors. If somebody only wanted to change the name, they only want to change the name and the material, or they only wanted to set the name and material, or they wanted to make a toy and they knew everything at that exact moment.
So actually the last one,
Yeah.
the only one we use the last one. The previous one is like part of like the toy string.
Right, but we can't. So this is separate location. So in order to call this, so the constructors are going to look very similar to each other. That's just how it works. They're going to look similar. Because you don't, from this constructor, you don't want to call this constructor. Because that has some bad side effects. Because now you're trying to create something inside of something. So they're distinctly separate. And we might have somebody just makes a toy and they only know the prices. So they say, maybe you're the dollar store and you know, hey, I'm going to have this many toys. I'm going to have 1,000 toys and they're all going to cost $1, but I don't know what they are yet. Then you create all of these toys, and then you're going to set their names later. So maybe there's yet another constructor that we would write for only setting the price, or having the default. Or if you're the dollar store, maybe you just have a default price of everything is $1, and then for the things that are only 50 cents, that you then go in and change just those. So sometimes your code is going to change a little bit based on its application, which is what it should do. The tailor should be built for how it's being used. So instead of our default price being negative a penny, everything could be $1 if we know that our code is running at something like a dollar store, where there is a default price for everything. And then if for some reason they're selling something that isn't that default dollar, they can go and change. It's much easier to change only 10 items than having to go in and set the price for every item in your store. Okay, cool. So yeah, constructors. They're really neat. Let's call this constructor actually. So let's. I'm going to copy this guy for reference, so I know what I'm doing in main. So let's call that guy. So you have a toy. What's another toy? Car?
Car.
Yeah, okay, so we have a toy car. Okay, and so then we're going to have the name, so it's a car. And then what is it made out of? What is this toy car made out of? Okay, we got a plastic toy car. And then how much is it going to cost? $10. Okay. So $10. And then and what's the minimum age for this car? Okay, 5 years old. So there we go. And that's what we would do. So we've utilized all those different constructors. We have our default constructor that's a Moppet. We have our first overload constructor that takes in just the name. We have the other constructor that takes in the name and the material. Then we have this final constructor that takes in the name, the material, the price, and the minimum age.
Can we just run it?
Huh? Oh, you want to run it? Yeah. Assuming these errors aren't critical, let's run this thing. Yeah, I don't know what this failed on disk. This isn't looking good. Here, let's copy and paste it. So, let's see. I have it here. So. and paste it. Bink. Okay. And G++, new toy. All right. Let's see. Cannot be overloaded. So let's see. Line 14. Oh. Let's get rid of these guys. Here we go. Compiles must be good. So there we go. So if we wanted to do more things, like we wanted to check that we had in fact changed all these things, let's call the getters here. So right here, let's. Am I using namespace? Yes, I am. So I can get rid of this. So I could say cout, and let's say car dot get name, and then get material. Let's see, get price and get minimum wage. Running out of new lines. Think. Okay. And this one. And it's rude to not give them the new line, so give them the new line. Okay, cool. So there we go. So now let's run it and take a peek. Bink, bink, bink. And there we go. So we see our car, we named it car. It's a type plastic. We got our 10 and we got our 5. We can even label them. What's up?
We use the saddle one?
Huh?
If we use the saddle one, just keeps the constructor closed.
Hmm?
If we use the saddle one.
The setters?
Yeah.
Well, we don't call it, so notice that's for you mean for Bobbit? Because Bobbit's the only one, I mean, Bobbit and Lego call the setter, but car never calls the setter. Car's default constructor does all of it.
Yeah. So for car,
yeah,
it don't need a setter one.
Right, it doesn't need the setters. Yeah. But we're using the getters.
Yeah.
So the idea, so maybe you have some privates that you don't want to ever change after the construction. You just wouldn't have setters. So maybe now we know that we have all these overloaded constructors. We never want to change the name. We essentially, the default constructor will be set the name to none, and then no one can ever change the name again. We could do that. We could just get rid of that one setter. Yeah. So there's constructors for you using the third class from last week. And notice that we didn't need constructors necessarily to be able to do everything last week. Everything worked without the constructors. But this saves us 4 lines, right? Because we would have had to call the setter 4 times. So it's nice. It's nice because of that. But also, it's tricky because if we forget to do our balance checking, like we forgot to check these, maybe the setters, they check these, but then in the constructor we forgot to change those, it could be a way that somebody could crash our program. Yeah. So, yeah, it's important to check. Let's see. The reason that we have constructors is because sometimes when we make these objects,
there's a setup. There's sort of like there's things that you want to create. So maybe you want to have an array. And you want to build the like during the constructor is going to set up the environment. Maybe you have a game. You have to clear the game board, and you have to make the game board. That's what a constructor is really good at. Is if somebody feeds into the constructor what's the size of the game board, and then it goes through it, makes an array of that size, and then sets everything to be empty. Versus us having to have a separate function that says like, hey, set up the board that you call. Okay, cool. So.
And that's a useful concept. You're going to use forever.
Well, we're
using these constructors.
We're gonna do it. We're gonna do it right now. Bam.
Thank you, activity. Constructors. All right. So we have our constructor. So we have a default constructor for the bank account, and then we have a normal constructor which is going to take in all of those things. So we're going to only have two constructors. We'll have a default one, and we'll have one that sets the name, account, and balance all at the same time.
So I don't know. Yeah, if you want to grab an expo marker, we got lots of those. Or if you want to do it on your computer, whatever's up to you. The whiteboard is cool because we can look at it together. Yeah. This was tricky because I think with this one, I had to use a new keyword, which I felt bad for. Don't do that. Everyone online.